Hi and welcome to Prototype. We'll be solving the problem for LeetCode 409 longest palindrome. This is another problem in the LeetCode 75 study plan. Let's get to it. So given a string S, which consists of lowercase or uppercase letters, return the length of the longest palindrome that can be built with those letters. Letters are case sensitive. For example, capital A, lowercase a is not considered a palindrome here. Given the input string S in the example of A, B, C, 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 D, D, it wants an output of 7. And the explanation is that one example of the longest palindrome is D, C, C, A, C, C, D. Or in other words, a string with 2 Ds, 4 Cs, and a single A, or a single B in this example. Okay, so we know a palindrome will have many even characters as it can have, an even number of characters as it can have, and then also, if available, one additional odd character. We couldn't add B to the string and have it still be a palindrome, right? We could replace A with B, but at most it can have one odd frequency of characters. If there were 3 A's in the string, we could add 2 more A's, one to the left and one to the right. All right. What's our first thought to solve a problem like this? I think we could just create a frequency hash map. So let's do that, or frequency set. I'll just use an object in this particular solution here. And so for const character of S, if the frequency is null, then initialize it to 1. Else increment the number by 1. Okay, so now we have a frequency hash map of all the unique characters in S and mapped to its number of occurrences. And now we're going to loop over the frequency values, right? And then come up with our result. So let's initialize our result to 0. And we'll actually also need a has odd flag. Again, palindrome can have at most one odd frequency of characters. Okay, and so for const f of object.values frequency, and all this is doing is creating an array of the values in the hash map. Okay, and then we'll need a check, and we're checking if the frequency is even, right? What do we do if it's even? We're going to increment our result by the frequency. So if there are 4 C's, right, we can add 4 C's to our palindrome that we're building. Else it's odd. So we've found an odd frequency. So true. So at the very end, we can, when we return, we can return a ternary operator, I guess. Ternary expression. And then if it is odd, then we just simply add 1 at the end. Okay. One other thing we need to do here is we need to add the odd frequencies as well, but we're only going to add the frequency -1. Okay. Why? Well, if there's one unique character, we can only add 1, and we're doing that at the end. Otherwise, if there's an odd number greater than 1, if there's 3, for example, if there were 3 D's here, we could still add at least 2 D's. We couldn't add 3 D's, but we could add 2 D's. And so that's why we also increment by the frequency, but -1 to take out the extra odd character. All right, let's run it. Okay, passes the test cases. Let's submit. Okay, 79.8%. All right, pretty good, but not the best. Let's do some quick analysis. So what's going on here? We're actually doing 3 linear operations. So we're going to run through each character of S. So our time complexity depends on the length of the string S. But we're also going to be looping through the frequency hash map, which technically is constant because there will only ever be 46 buckets in the frequency hash map. So technically it is constant. There is a finite number of buckets. But we're also doing one more linear operation here, which is getting the values from the hash map. Okay. So not the best. In terms of space, we're also going to be, again, using 46 buckets of space. So technically constant as well. But can we do better? Can we do better? Okay. Is there a way to do the result calculation as we're traversing the letters in the string? Is there a way to keep track of the result as we're going through the string? And the answer is there is. How do we do that? Well, okay, so we're still going to go down the string, loop down the characters of the string. So for const character of s, and we'll be trying to keep track of the result as we do this, right? So we'll need result variable. And then what is the best object to do this? Let's use a set this time. So I'll just call it set, and I'm not going to call it frequency this time. So just a set. Could use something else too, it doesn't really matter. And we'll do the same check in the as if we were creating the frequency hash map. So if the set has C, or let's do the does not have C first, then set add C. Add the characters to the set. Else, we can actually just remove the character. And why are we removing the character? Because now we know that we found a matching pair. We've found a matching pair. So if we were traversing down the string, we'd have we seen A? We have not added to the set. Have we seen B? We have not added to the set. Have we seen C? No, so add to the set. Have we seen C in the fourth character in this string? Yes, we have. So we know that there's two. There's a matching pair. We can just increment the result right away and then remove the C. Why remove the C? Well, I'll get to that in a sec. Okay, so as we've traversed along the string, we've come up with a result, and the result is going to be the longest palindrome, if it is a string with only even unique characters. We still need to handle the case where there's at least one or more unique frequency of unique characters. Okay, how do we do that? Well, we're going to return the result, and we can also return another ternary expression based on the set size. Okay, based on the set size. And I'll just use a cast to a Boolean value here. Okay, in JavaScript, if it's 0, 0 is a falsy value, anything that's not 0, or nan, I guess, technically still a number, is a truthy value, okay? So if the set size is greater than 0, okay, just add 1, else add 0. How does this work? Well, notice in this string, we would have at the very end set with A and B. It's a set with only A and B. The even frequency characters have been removed because once we find the even pair, the complement, you could say, we remove it from the hash set. So the hash set will only have a size if it has found unique characters with an odd frequency. And so we can use that to adjust or to offset the result. Okay, let's run it. And submit. Oh, so it is faster, 92.22%. So a little bit better than what we were doing before. And as you can see, it's cleaner, smaller solution, less code, and we do it in a single loop. So now we're only dependent, at least in terms of time complexity, on S and even space. We're, with at least some probability using less memory, because we're not going to, we may not, I should say, maintain a set with 46 buckets. Although I guess if this was to be even more performant, we'd just use array with size 46 instead of using the add and delete operators. We can just increment and decrement the array. But anyway, that is the solution to LeetCode 409 longest palindrome. Subscribe to see more. We'll be doing the rest of the LeetCode 75 study plan in short order. Thank you, and see you next time.